Today, we're going to learn how to add a node to a singly linked list. Hello, I'm James Helfrich. The linked list is similar to an array in that it both can store a collection of elements. An array, every element is guaranteed to be next to each other in memory, but the linked list, that's not necessarily the case. So we're going to learn how to add new elements to a linked list in this demo. We'll start with our definition of a node. This node is going to have an integer data type and a singly linked list, which means I'm going to only point to the next node in the sequence. So we'll start by allocating a new node and setting its value to 7. P is going to point to the first node. Next, we want to add another node. So we're going to allocate a node to P arrow P next, and then we're going to send that data, P arrow P next, its data to 8. So now we have two elements. Observe how node 7 and node 8 do not have to be next to each other in memory. We only know how to get to 8 from 7 by the P next pointer. Now I want to allocate a new node. So the first node is P, the second node is P arrow P next, and the third node which I'm going to allocate is P arrow P next, arrow P next. I'm going to set the value to 9, and then I'm going to set its next pointer to the null pointer. And this indicates that the linked list has an end. This is a linked list of 3 elements.
Here is a second example.
Initially, we're going to allocate one node and set its value to 1. Next, we're going to allocate a new node and set its value to 2. Observe that node 1 and node 2 are not connected in any way. Now we're going to allocate a new node and set its value to 3. Once again, these 3 nodes are completely independent of each other. Now I'm going to send P1 arrow P next to null. This means that P1 is the last node or the end node of this linked list. Next, we're going to set P2 arrow P next to P1. This means I'm going to jump from P2 to P1 and then to the end. At this point in time, P3 is not connected to the other 2 nodes. Finally, I'm going to set P3 arrow P next to P2. At this point in time, P3 is the head of the linked list, P2 is the second node, and P1 is the third and tail node. In this case, the linked list is set up in the opposite direction you would expect.
This third example will be a little bit more complicated.
Initially, I'm going to allocate one node, and I'm not going to give it a value. Then I'm going to allocate P1 arrow P next. So now I have a 2-element linked list. Notice how there's, again, no value. Now I'm going to allocate P2. Notice how P2 is not connected to P1 in any way. And P2 arrow P next will also get a node. So now I have 2 linked lists, each of length 2, and none of them have any elements. Now I'm going to give P1 the value 2. Now P1 data times 2 is 4, and I'm going to assign that to P2 data. So now P2 has a value 4, and P1 has the value 2, and nothing else does. Now P2 is going to be 4, times 2 is 8, and 8 is going to be assigned to P2 arrow P next, arrow data. Now P2 arrow data, P2 arrow P next is going to have the value 8, multiply that by 2, and that's going to be 16, and I'm going to assign that to P1 arrow P next. So now I have 2 linked lists. P1 is going to have the value 2 and 16. P2 is going to have the value 4 and 8. Now I'm going to say P2 arrow P next, which right now is null, but now it's going to point to P1. And now these are connected. Notice how P1 is a linked list of 2 nodes, and P2 is a linked list of 4 nodes.
This final example will add elements to the linked list using a loop.
First of all, we'll allocate a single node and put the value 10 in there. P will point to that single node. Notice how the next pointer is the null pointer. Next, we're going to have I equals 20. We're going to create a new node, which is the next node after P. We're going to assign the value 20 to that data item and set the next pointer to null. Notice how P advances to the next node, and that happens from P equals P arrow P next. Now we're going to set the value to 30. And once again, I'm going to allocate a new node with the value 30. I'm going to add it to P arrow P next, which is the node after 20, and set P next to null. Then I'm going to advance the pointer. Now I will be 40. Once again, I'm going to allocate a new node after 30. I'm going to make that p equals p arrow p next, so it's going to advance p and set the next pointer to null. Now that I equals 40, I will exit the loop. Observe how I have a linked list of 4 elements. However, p only points to the 4th element with a value 40. I have no access to node 10, 20, or 30. This actually makes it impossible to delete those elements because we have no reference to where it was. This is example 4.1, 4.3, 4.4 in the C++ data structures textbook.